All right, welcome to chapter 5. 5.1 is graphs of reciprocal functions. So now we learned a bunch of functions. So we're going to flip them. We're going to say 1 over that function, or further than that, a function over a function. We know how to divide polynomials. So we're going to discuss graphing these divisions or these reciprocal functions throughout chapter 5. Trying out the new audio. Let me know if it's better or if it was just as good before. Okay, so I graphed a line here. It's a function 2 minus x. Y-intercept is 2, slope is -1. Easy stuff. And now we want to graph the reciprocal function. So remember, the reciprocal is just 1 over a number. So the reciprocal of 5 is 1 over 5. The reciprocal of 2 over 3 is 3 over 2. It does not change the sign. A lot of guys get confused with negative reciprocal from grade 9, perpendicular slopes. It's just flipping the number, reciprocal. So think of this function, all these y values. If I flip the function, all the y values flip. So it's really easy when you have a graph, because I can take any point that I see and find the reciprocal. So this is an obvious one, right? This goes through the y value of 2. Now ignore the x values for now. But if it goes through the y value of 2, the new function must go through the y value of 1 over 2. So that's a guaranteed point. I like putting guaranteed points immediately on my graph. Some other things to consider. When y is 0, 1 over 0 is undefined. When y is 0, 1 over 0 is undefined. This means that this has to be a vertical asymptote. I can't touch that y value, that x value, in the reciprocal function. And you can see right here, right? 2 minus 2 is 1 over 0. That's not allowed. Okay, but you can also consider it using the graph. If the function goes through 0, you know the reciprocal function is undefined. So we put a vertical asymptote. Now, other things to consider. Positive and negative intervals. If I flip a function, it does not change the sign. So if it doesn't change the sign, all these points that are positive in the reciprocal function have to remain positive. They're never going to come down here. And likewise, all these negative values are going to stay down here. So it's really important to know where your new graph is going to be drawn. I know it's going to be drawn there. I know it's going to be drawn here. You kind of think of it as 4 quadrants, and you're usually only graphing it in 2 or opposite quadrants. Okay, now I want to find out some other points. I like the y value of 1. So wherever this line equals 1, I like that point. Why? Because the reciprocal of 1 is 1. 1 over 1. So it's always the same. This is the intersection point of the function with the reciprocal function. And I know that as these numbers get greater, let's say 7, it's 1 over 7. So as they get greater, these get smaller and smaller. So I'm going to have something that looks like this. And as the number gets closer and closer to 0, 1 over a small number is a very big number. Okay, so we actually also have a horizontal asymptote at y equals 0. Now this is true for all reciprocals of lines and reciprocal of parabolas. You always have a y equals 0. Remember this. When we discuss the range can never be whatever number is out there. And when we're finding the reciprocal, we never have the number out there. Because if we had it, it would be in the denominator. So it's always y equals 0 being your horizontal asymptote. You can't touch it. And when you see these dotted lines, if you draw them in, you know your line can't touch it. It's pretty obvious where to draw your graph, especially when you have 2 points. Like, okay, kind of got to go this way. This one's higher. Okay, likewise over here, pick a random point. Let's say, actually -1. I like -1 too. Guess why? Because the reciprocal of -1 is also -1. I'm going to pick this 7, and 7 is the same thing, right? It's going to be, this 7 is going to be -1 over 7. So this is going to be the same thing like this. Okay, kind of approach the asymptotes, and this is graphed. Now let's take a look at the intervals of increase and decrease. This one is decreasing from right to left. But look at the blue line. It's increasing from right to left. So while the positive and negative intervals stay the same with the function and its reciprocal, the interval of increase and decrease flip. So if I know that this function is going downwards, I know that the new one that I have to draw has to go up. Okay, so knowing all these little things, the ones, the decreasing, the positive, negatives, help you graph the reciprocal without even considering the graph. I mean, this is just a regular 1 over x function. It's flipped in the y-axis and it's shifted to the left, to the right too. Okay, because you got to factor out that negative. It's not a positive 2, it's really a negative 2. Okay, so pretty straightforward graphing reciprocal functions. We're going to move on to parabolas now. Here it is. We have the function 9 minus x squared. So this is a flipped parabola, opens down because the a value is negative, and we have a positive 9, so it shifts it up 9 units. Let me get my pink marker. I want to graph the reciprocal. I'm going to do the same thing that I was talking about before. First of all, I have a horizontal asymptote at y equals 0, because it's a parabola, and all lines in parabola have this. My x-intercepts, look, I have 2 of them now. I have 2 x-intercepts. This has to be a vertical asymptote on this reciprocal function. Has to be. Draw them in. Now, pick some easy points. Remember the easy points? The 1s are intersection points. The negative ones are intersection points. The 9 is kind of like either a local minimum or a local maximum. So I like to flip that into a 1 over 9. Okay, I flip it. 9 becomes 1 over 9. And I know that this is increasing here, so it has to be decreasing here. This is decreasing here, so it has to be increasing here. And be careful not to hit the asymptote. Kind of graphed it a little ugly, but it's okay. Okay, now I have my new graph that looks like the same color, unfortunately, in this section. And I have to graph now in this section. Now there's nothing going to be here because nothing in the regular function was here. So I'm going to graph this guy, and this guy. And I already have a point here. If I want to find out other points, plug in the y values. This is like a -5, so it's going to be 1 over -5, or -1 over 5. So I know this is going to approach the asymptote here. This is going to approach the asymptote here, and here as well. Now they always look like this. It's kind of like easy to just guess how it's going to look. This was probably the difficult part, but I mean, once you know parabolas, it always looks like that. So I mean, it's not that difficult. And then once you have which quadrants you're going to draw in, or not quadrants, but which sections you're going to draw in, first of all, they're always opposite. That's a nice thing to know. And you're always kind of just estimating along your asymptotes. The function usually approaches the asymptotes on both sides. So knowing those few things helps you graph reciprocal functions pretty easily. Now, what if you're just given the equation and you don't really know how to graph the reciprocal function? You don't want to graph this. Okay, can you graph that in 2 seconds, like a grade 10? Yeah, of course. 9 minus x squared should take you under 10 seconds to graph that.
Sorry for the delay for break, guys. At this time,
so,
we have A and D. Go to break, please.
Graph the regular function.